So let's talk about ethical AI, that is responsible AI practices and the importance of addressing biases. So we have an organization called OWASP. So this is Open Worldwide Application Security Project. This is a non-profit foundation that works to improve the security of software. So before you develop any of the large language models or any of the generative AI application, right, you need to follow certain guidelines. So for example, let's say if I am sending employee information like email address or date of birth or name, etc., right, as a prompt to the model. So when you send this information to the model, all this employee information will be passed to the LLM. For example, let's say OpenAI LLM, right? Then that information will be saved on the OpenAI server, right? So you are sending your employee information to the large language model, and assume if any employee leaks any information from an organization, then that information will be leaked. So which is called sensitive information disclosure. So generally companies will ask for the complete domain specific data that you will be using for fine tuning the model, and that data will be sent to the cybersecurity team. Then they will use a third-party tool and scan the entire data that you will be passing to an LLM. And if they identify any sensitive information, you won't be able to proceed further even with the proof of concept itself, right, when you're using a paid tool. But whereas let's say if you're using any open source model, then you can skip this step because you are storing the data in your local server and you're not sending it anywhere, right? And sometimes companies use PII reduction techniques also. They'll try to mask the PII information, that is any sensitive information they'll try to mask before they actually send it to the LLM. So the better you understand most of these 10 threats to an LLM, then the more secure the model is, right? So it is very important to take care of these LLM threats while implementing any generative AI model, either building from scratch or fine-tuning an existing pre-trained model, right? So you can secure the data and you'll be able to build a reliable, safe and secure model, right? So we have a total of 10: prompt injection, insecure output handling, training data poisoning, model denial of service, supply chain vulnerabilities, sensitive information disclosure, insecure plugin design, excessive agency, over reliance, model theft. So let's deep dive all these 10 threats. The first one is prompt injection, right? So an attacker can prepare a crafted prompt and they can send it as an input to an LLM. So the LLM can execute the prompt and that can lead to data exfiltration, right? For example, let's say an attacker can employ an LLM to summarize a web page which contains an indirect prompt injection, right? And how do we prevent this from happening? To prevent this, we need to make sure that we are not giving excessive privilege to access the backend systems, right? So make sure you always provide the enough access, or try to make sure we have human in the loop, right? When we have extensible functionality, instead of completely giving access to LLM and relying completely on the model, make sure we have human in the loop when we have extensible functionality. And we also have to make sure we have established trust boundaries between LLM, external data sources and extensible system functionality, right? So we need to make sure we segregate the content that we will be accessing from the external systems, so the prompts cannot directly access the data. And few scenarios, right? For example, like I said, an attacker can inject a prompt to an LLM based chatbot as an input and make the LLM to summarize the web page which contains a indirect prompt injection, right? So that's about the prompt injection. And the next one is insecure output handling. So let's say you have a downstream application which is consuming the output that was generated by a large language model LLM without even checking what the LLM was actually generating, right? And with this, we may be able to hack and execute the remote code on the backend systems, which can lead to security concerns, right? So for example, so without cross-verifying the output that was generated by an LLM, if we use that LLM output in our application, that can execute some remote code and can cause security concerns, right? For example, JavaScript or Markdown is generated by an LLM and returned to the user, and that can result in excesses, that is cross-site scripting, right? And how do we prevent this? So make sure to apply proper input validation techniques. So when consuming the output that was generated by an LLM, instead of blindly consuming, make sure you have proper validation techniques in place, and also try to encode the output that was generated by a model so the user may not be able to interpret the undesired code, right? And some of the attacking scenarios, as I said, without proper validation of the output that was generated by an LLM, if we try to pass that as an input to our system, that may execute some of our system commands and can lead to malicious results, right? Another scenario could be if a user uses a website summarizer LLM tool that can generate the summary of an article, which includes a prompt injection, right? And another scenario could be an LLM allows the user to craft an SQL query through a chat-like feature, so it can execute the backend database and leak some of the confidential information. So it is very important to validate the output generated by an LLM before we actually consume that output in our application, right? And the next threat could be training data poisoning, meaning manipulating the model training data or model fine-tuning process so that an attacker can introduce vulnerabilities and that can compromise models' security, right? And this can impact downstream software exploitation, right? Some of the examples are, so an attacker can prepare the training data document with inaccurate information and assume once the model is trained with this inaccurate training data, right, the attackers can gain the information that they are expecting from the application, right? So how do we prevent this from happening? So we want to make sure we are verifying the data sets that we will be using during the model training or training process, right? And also make sure you guardrail the training data with proper filters which can identify any malicious intent. And what are some of the attacking scenarios? If the training data is not accurate, obviously the model will predict the biased results, right? So an attacker can prepare a prompt that can inject toxic information, or your competitor can create inaccurate or false information that can target model training data, right? So we want to make sure we sanitize and have enough data filtering techniques in place in order to avoid data poisoning, right? And the next one is model denial of service. So model denial of service can happen when an attacker tries to interact with an LLM in a way that the LLM consumes exceptionally high amounts of resources, that is GPU, right? So that can lead to resource cost, right? And as a result, it can impact the performance of LLM, and it will impact whoever is using an LLM with a high amount of resources, and also it can impact other users as well, right? Whoever is using the LLM. So as an example, an attacker can prepare a query that can lead to recurring resource usage of LLM, that is by making the LLM generate a high volume of tasks in queue. Or an attacker can send queries as an input to an LLM that can consume high resources, right? Another example would be continuous input overflow. That is, an attacker can send a stream of input to the LLM which can exceed the context window. Once you exceed the context window, that means you are utilizing high amount of resources, right? So how can we prevent this problem? Like I said, try implementing input validation rules. That is, add a limit to the input that we can send to an LLM, right? Make sure we have a limit. And try enforcing API rate limits so that we can restrict the number of requests that an attacker can make. Okay, and try limiting the number of actions that can perform as a queue so we can avoid resource consumption. And few of the attack scenarios are, let's say an attacker sending multiple requests as an input to the LLM, which can lead to resource consumption, right? And another one could be an attacker can send a benign query to an LLM to see some intended text on the web page. Or another one could be an attacker overwhelming the LLM by sending a huge input which can exceed the LLM context window, right? And the next one is supply chain vulnerability. So that means supply chain vulnerabilities in LLMs can compromise model training data, machine learning models, and also deployment platforms, right? So which can cause biased results or security breaches, or maybe an attacker can bring down the entire system itself, right? So these vulnerabilities can happen when we are using some outdated software or susceptible pre-trained models or poisoned training data or insecure plugins, right? So for example, let's say if you're trying to use outdated third-party packages, right? So always make sure to use the latest version of the packages to avoid any vulnerabilities, right? And another one could be fine-tuning with a vulnerable pre-trained model. So make sure the pre-trained model that you're using is always safe to use before you use it, right? And another one could be training using poison data, right? So always make sure you have the quality data. And another example could be using a deprecated or unmaintained model, right? And how do we prevent this from happening? So try using independently audited security systems, and also try using trusted plugins, and make sure you have MLOps best practices are in place for all the models that we are using, and make sure to monitor any vulnerabilities, and also regularly review the supplier security and access. So what are the attack scenarios? So an attacker can trick developer by a compromised PyPy package, right? Or publicly available models can be poisoned, and those model can spread misinformation, right? So that's why you have to choose the right model. Or a compromised supplier employee can steal IP information also, or an LLM operator can change the terms and conditions in order to misuse the application data, right? So you always make sure you read all the documentation that is available, and make sure the model is up to date, and the third party packages that we are using, they're also up to date and safe to use, right? And the next one is, this is the sixth one, sensitive information disclosure. We already talked about it. That is, LLMs can disclose sensitive information or proprietary algorithms or confidential data, which can lead to unauthorized access, intellectual property theft, and privacy breaches, right? So to avoid these risks, what we have to do, we'll have to make sure to sanitize the input data that we are sending to LLM, and also try implementing appropriate policies, and also restrict the types of data returned by the LLM, right? Few examples can be incomplete filtering of sensitive data in responses. So always make sure we have the filters in place for both input as well as the output. Whatever we are sending to the LLM as an input and what we are getting from the LLM as the output. So make sure we have the filter in place, and also overfitting or memorizing sensitive data during training. And another example can be unintended disclosure of confidential information due to errors. So how can we prevent this from happening? Like I said, use data sanitization and scrubbing techniques, and implement robust input validation and sanitization. So make sure the validation techniques are in place, and also try to limit access to the external data sources. Let's say if your application uses any external data source, make sure these models do not have those external data source access, and also apply the rule of least privilege when training models, right? So try to give as much least privilege as possible, and maintain a secure supply chain and strict access control. And some of the attack scenarios can be, an attacker can craft prompts that can be used to bypass input filters. Let's say if you add any input filter, an attacker can craft a prompt that can bypass the input filters that are in place, and reveal any sensitive information, right? And also personal data leaked into the model via training data increases risk. So always make sure the data that you are training doesn't have any sensitive information. And the seventh one is insecure plugin design, right? So the plugins can be prone to malicious requests, leading to harmful consequences like data exfiltration, remote code execution, and privilege escalation due to insufficient access controls and improper input validation. This is again, make sure as a developer you follow robust security measures to prevent exploitation, like strict parameterized inputs and secure access control guidelines, right? So few examples could be plugins accepting all parameters in a single text field, or raw SQL or programming statements, right? Another example could be trying to authenticate without any explicit authorization to a particular plugin, right? Or plugins treating all LLM content as a user created and performing actions without any additional authorization. So always make sure we have the authorization techniques in place, right? So how do we prevent this? Like I said, try enforcing strict parameterized input and perform type and range checks, and also try conducting thorough inspections and tests, including SAST, that is static application security testing. DAST means dynamic application security testing, and IAST means interactive application security testing, right? So these are the different testing techniques. So make sure they are in place, and also try having authentication in place when you are trying to access any APIs, right? And also try having manual user authorization for actions taken by sensitive plugins. And these are some of the attack scenarios. An attacker can craft a request to inject their own content with controlled domains, right? Or an attacker can exploit a plugin accepting free form input to perform data. Or an attacker stages a SQL attack via a plugin accepting SQL where clauses as advanced filters. So make sure you enforce proper authorization techniques in place when you are using the plugins. And next one is, as the name suggests, it is excessive agency. So excessive agency in LLM based systems is a vulnerability caused by over functionality, excessive permissions, or too much autonomy, right? So try preventing by limiting the plugin functionality. So use it only when it is absolutely needed, right? So don't try to give excessive permissions. So an LLM agent accesses unnecessary functions from a plugin, right? So these are different examples here. And an LLM fails to filter unnecessary input restrictions, right? Or another example could be a plugin possesses unneeded permissions on other systems. Or an LLM plugin accesses downstream systems with high privileged identity, right? So these could be some of the examples. And how do we prevent it? So always try to limit plugins tools that LLM agents can call, and limit functions implemented in LLM plugins or tools to the minimum necessary. So this is kind of self-explanatory, right? And avoid open-ended functions and use plugins with granular functionality. And also make sure we have human approval in place when we are trying to authorize, right? And also log and monitor the activity of LLM plugins or tools and downstream systems, and implement rate limiting to reduce the number of undesirable actions. And we already know an LLM based personal assistant app with excessive permissions which can send malicious email. So this could be prevented by limiting functionality, permissions, requiring user approval, or implementing rate limiting, right? So always make sure you do not provide excessive permissions to these LLMs. And the next one is over reliance, right? As the name suggests, over reliance on LLMs can lead to serious consequences such as misinformation, legal issues, and security vulnerabilities, right? So don't always try to rely on LLM output, right? It occurs when an LLM is trusted to make critical decisions or generate content without adequate oversight or validation, right? So when you are trying to make critical decisions, don't just rely on LLM generated output, right? So always make sure we have human in place before we consume the output that is generated by an LLM. And the last one is modal theft. So LLM modal theft involves unauthorized access to and exfiltration of LLM models, risking economic loss, reputation damage, and unauthorized access to sensitive data, right? So how can you prevent this? So always make sure you have security measures are in place in order to protect these LLM models, right? So we discussed all these 10. So make sure you keep all these 10 in mind whenever you are trying to use any large language model, right? So do not just blindly use any model, all right? Thank you.